Hello, students. Today, I will cover some basic analysis methods that are commonly used in ergonomics to find design problems in existing products and systems so that designers can design better solutions. Without analysis, you cannot expect that your design will be a better solution that already exists. Analysis is essential in ergonomics and any design approached. Now I will cover two basic methods, task analysis and usability analysis, what they are, how to use them, how to apply them in real projects. So we will discuss these things today. Now, a little bit about analysis before we get into the analysis methods. Ergonomics without analysis methods cannot really exist, because analysis is used to find problems in existing products and systems. So you use analysis methods to find problems in the design. As we know, design is about what? Basically, having a problem and solving this problem. This is the goal of design, the main goal. Usually, it's about problem solving. So, analysis methods help us in this, help us discover problems so that we can solve them later on. Now, so imagine if designers cannot discover what problems exist in a design. You have let's say a product, and you cannot discover what problems it has. Then obviously you cannot solve them. You cannot solve problems that you fail to recognize. So again, our scissor, for example, if I don't know what the design problems is with this, how do I expect to be able to solve them? I can take a paper and I can draw hundreds of scissor shapes, of different shapes, but I'm not solving any problem here. I'm just drawing art. I'm not designing. Real problem solving and real design comes with, first, finding the existing problems in the product type that I plan to design. So I would, for example, if I want to design this scissor type for this function, what is its function? Because we have many types of scissors, okay? So what is this one's function? Then I will take, for example, a lot of designs that are similar to this, and I will analyze each one of them using methods that we will talk about. And then I will write down all the problems that I discovered so that when I start drawing and designing my version of the scissor, so that it is going to be a better version, basically to solve a problem or to solve several problems existing in this. So analysis methods is crucial for this. If you don't know any methods for analysis, it's very difficult to just look at this and tell me what are the problems here. It's not easy to identify. So this is because analysis methods help you to break down complex problems into small parts that are manageable. Now, if I have a complex design situation that I have to solve problems for, first find problems, then solve them. Now, if I have a complicated situation, I cannot just look at it and say, okay, I have the problems, I found them, 1, 2, 3, 4. You can't do that. You need to use methods that will break down the complicated situation into small parts, which you will be able to look at separately. Like, for example, now I focus only on this part and decide what are the problems. Then I focus on this part and decide what are the problems, and so on. Because when you have a complicated situation, your brain will easily miss details. So analysis methods help us to break down complicated situation into small parts that are manageable and can be solved step by step. So this is why we need methods. Now, in ergonomics, they use many methods. And most of them are really complicated. We, in our class, cover the basics, very basics and most simple methods that you can apply in any project, whatever field of speciality you are. These methods can be applied to almost any project. So let us see our first method. This is called task analysis, a method for analyzing called what? Task analysis. So now, task analysis, you already know what tasks are. I said before, explained many times, that at any point during our day, we are actually, when we are moving, when we are doing something, we are performing tasks. If I want to cut with this object, okay, I will place it in my hand and I will, for example, the cutting process is performing a task. When I take this scissor, for example, and I clean it, for example, it's dirty and I have to clean it. That's also performing a task, another type of task. So depending on the function of certain products, the tasks performed are also different. So you're performing each day hundreds of tasks, really. You're performing tasks all the time. All the time you're coming in contact with products. I'm in contact now with this cup. And the task I'm performing is drinking this coffee, okay? So, performing tasks. So, this is a task analysis method. So how does it work? Task analysis, okay, is basically assessing, which means like understanding what a user does and why. Who's the user? The human that will be using this whatever product, okay? So what is the user doing and why is he doing it? Step by step. So this method will analyze what the user does and why, step by step. And we will use this information as a designer to design a new and better product or system. Now, sometimes analysis methods, just so you know, are used just for analysis. Like, for example, I want to discover the problems in this design and not go further to actually design them. It depends on the project you're working on. Sometimes you have to find problems and design the problems. I mean, solve the problems, sorry. Find problems and solve problems. So it depends what project you're working on. So here are just some images of people performing tasks using all kinds of different products. Now, to make anything, okay, ergonomically sound, meaning correct, ergonomically, okay? You need to always keep in mind these three things. And to use this method, the task analysis, these three things are important. The body mechanics, the tool or machine used, and the task being performed. So you need to very well understand this. So the body mechanics is how the body really functions, how the body moves when in contact with this product, all of these details regarding the human body. It's actually very complicated if you go into the details of body mechanics. In our class, we just talk about it in general. So you need to understand, if you want to really understand body mechanics, you need to, you will find complete books about it, full books about body mechanics. It's not so easy. But we look at it in a general way. If in future you need more information, you can always improve your information by reading more. So the tool or machine used. What is the tool or the machine that is being used? You need to understand it. If I don't understand what this is, if I don't understand everything about it, it will be a problem. If I don't understand, for example, okay, why did they put this here? You see this part in this place? Or why did they make this here in this shape and this in this shape? Why did they put a different material from the inside than the outside? If I don't understand, then I will not, it will be a problem for me to find the design problems in this, for example, product. And the task, I need to know what tasks are being performed using this tool, product, machine, call it whatever you want, system, okay? So what are the tasks being performed? Sometimes it is just one task. Sometimes you have 5, 10 tasks that can be performed with one product. So we need to know all of the tasks that can be performed, okay? So we need to understand these three things before we can move on. So we already explained the task analysis will help you understand what you want to do, what you want to design. It will dissect a complex set of actions and turn it into simple ones that can be evaluated easily. I already explained that. The complex situation made into small, simple parts that can be managed separately, solved separately. So we need to understand, as we said, what tasks are being performed when using a certain, let's say, product. So we need to break down now this task. Break down into separate parts. Now, to do that, we need to understand, okay, where are the human-machine touching points? Now, I said about this thing many times before that it's very important because when we use any product, anything in our daily life, we come in contact with it. Okay, we become a system. So I'm in contact now with this product. So where are the human-machine touching points? Where are the touching points between the human and this, call it a tool, a machine, a system, whatever you want. But where are the touching points? So we need to identify when I am using this. So when I'm performing a task, where are the touching points? Now, when I'm cutting, do I touch this part? No. Do I touch this part, the handles? Yes. Which part of the handles do I touch? Which parts? This part or this part? Okay. With what I am touching it? With what? It's not enough to say my hand. With what? With the fingers? With which fingers? Do I put this finger here or do I put these fingers here? There is a difference, okay? you need to make sure that every detail you explain. So what are the human machine touching points, okay? And where? Okay. Then you have to describe the actions. Now we will look at an example in a minute, so it will a little bit clarify a little more. So we need to say what task we need to do step by step, then identify the human machine touching points, and then talk about the actions. What exactly happens when I'm using this product? So, and after that, after we have these 3 points, we are in a better position to what? Identify which of the steps which have certain design problems in them. Or, for example, take a lot of effort or time to complete which of the steps of the task, okay? But without breaking them down into step by step, it's hard for us to identify the problems. So let us see a simple example. Using a vacuum cleaner, the task is vacuuming, okay? Here is the vacuum cleaner. So the task is vacuuming the floor using a vacuum cleaner. Now the vacuum cleaner is a complicated device. What we have here is a simplified version of a real vacuum cleaner task analysis. The task analysis of this device, it has so many details in it. It will be much lengthy and it will have several tasks, okay, not one task. Anyway, this is a simplified example. Now, the task steps for using a vacuum cleaner to vacuum the floor. In simple terms, okay? You have to first, for example, to uncoil the power cord. You know, the electricity cord, you have to uncoil it. Then you need to plug it into the power cord. Okay, plug in the power cord into the outlet. Then turn the vacuum cleaner on. You have to what? Press a button which says on. So you can make the vacuum cleaner start working. Then what do? What is the next step? Maybe you take the handle in your hand, okay? You grab the handle. Then you start pulling, retracting, and, you know, like doing this with the handle to clean the floor. Then what do you do? So it's like a step by step. What do you do to do this task, which is vacuuming the floor? Now, this is here, again, my scissor. Cutting, for example, with this scissor. What could be task steps for this? For example, first step, taking this scissor into my hand, okay? Placing it, for example, in a certain position, okay? Then, for example, with the other hand, holding, for example, a paper. Then start moving the scissor, for example, opening and closing the scissor to perform the cutting. Then what do I do? So it's like really pay attention to the step-by-step process. From the start, when you touch the product, to when you finish the task. So sometimes the task steps can be a lot, many. And you can have more than 2 tasks performed. Like, let's take this one as example again. So I can cut with this, and I can change the knife inside. Now, changing this blade inside, this requires different task steps than if I am using this for cutting. For cutting, maybe I will place it in my hand. I will push this, okay, in a certain way. Then I will place it in a certain way and start cutting, for example, okay? But If I want to change this blade, I have to do totally different task steps. So I have to open this part here. I have to retract the blade. I have to take another blade and place it in its position, and so on, and so on, and so on. So with one product, you can have more than one task that you can complete. If that's the case, you will have to do two different task analysis for it. You cannot place two tasks into one task analysis. You cannot. So this is, for example, for a certain task broken down into steps. If I have to do another task with the same product, I have to do this all over again. Again, write the tasks down for the other task that I'm performing. So this should be very clear to you, because when you have later products that you will basically do in your projects, you will have to analyze them, do a task analysis, and you need to be clear about that. What are the tasks performed? And for all of them, you need to have separate tasks analysis written down, okay? So this is about the task steps. So we broke down the task steps from the start till we finish using the product and we put it back in its place and we have no contact with it anymore. Now, we also need to always identify what the human-machine touching points. So here we have a vacuum cleaner. There will be touching points between the human and the power cord. There will be touching points between the human and the power cord plug, the vacuum cleaner switch, the on-off switch, the vacuum cleaner handle, you know, the handle, this part here. So maybe there will be contact even, this is a simplified version, as I told you, so it doesn't include all the points. But for example, sometimes the foot is used to get in contact with certain parts of the vacuum cleaner too. This needs to be mentioned. So here you mention where are the contact points between the human and the machine. You can mention the part of the product that the human comes in contact with and the body part that comes in contact with. For example, my hand with the handle of this product. And you can even go into more detail saying which fingers come in contact with this and which fingers come in contact with this part. So it can be made much more detailed as a description. So identify all human-machine touching points, where they are and what they involve. In the future, don't worry if you don't know certain parts, for example. Okay, what can I call this part? What's the name of it? Or what's the name of this? You don't have to worry about it. You can just use a picture or pictures, photographs, okay? And you can indicate, this is the part I'm talking about, okay? And for example, these are the touching points, this part, this part, this part, and then you can have a human hand or a human hand actually using this, okay? And you can say what the touching points are. So if you don't know the naming of certain parts of the product, don't worry about it. You as designers can always use images to help you explain your ideas. We will talk about this later when we get to the projects. Now, okay, so the task steps for a certain tasks and the human-machine touching points need to be identified. Then come the actions. So what are the actions? How do we write about those? So the action is basically, well, what does action tell you? All of you know what action is. So something is going on, it's in movement, it's you know, the action of the situation. So when I have this here part, identifying the task steps, it's in a very boring way, you know, like step by step by step by step, saying what are the tasks. Here we have also outlined the human machine touching points, but in a very like there is no action here. It's like identifying, okay, my hand touches this part, or this finger touches this part of the product. That's it. But when we have the actions, we explain the situation like, okay, for example, you take each one of these steps, you see, each one of these steps. For example, the first step, uncoil the power cord. Here, uncoil the power cord, and you explain the action, what's really happening. This is the task steps plus the human machine touching points together. What do they do together? Okay, so the first step, you use hands and arms to uncoil the power cord, and your back for bending, you bend over the whole body to reach the cord storage location. Cord needs to be unwound and wound around guideposts a dozen times. Okay, so if you read this, you get the whole action. You understand the action, what's going on. So exactly how do you use your hands to do this task? How do you use it? Which parts? What do you do? What kind of movements? Okay, so you explain the action of the situation. Then you take the second task step, plug in power cord, plug and plug power cord. Okay, you have to do what? You have to use your hands to hold and push and pull the plug into the power outlet. And you need your legs to walk to the power outlet. So you explain all the dynamics, all the action that the body does. Okay, remember this, what we said here, the body mechanics. Okay, so you explain everything, what you do, what the body needs to do this task. So you put the task step plus the human machine touching point together, and you tell me what are they doing together to do, okay, to explain the action. Because if I read this alone, okay, I understand the steps. If I read this alone, I understand there are touching points in certain places, but how does this here with this, for example, come together as an action? You need to explain that, okay? Then you take the third step and the next step and the next step, and you explain what actions, what body parts are used, how are they used, if other parts of the body need to be used, like your back needs to bend, you need to walk towards this item, you need to move other body parts while doing this task without them coming even in contact with the actual product. This is also important. Sometimes you use your hand only, but your whole arm is actually being used also. It's like I'm using my hand, but I get pains here while using a certain task, even though I'm using my hand. So how this happens? Maybe I'm using this, whatever I'm using, in a wrong posture. My body is not in a good posture, so I get all kinds of other problems. So you need to explain the actions of every step of the task, okay? Here, this one, for example, vacuum the carpet. So you're in this task step now, vacuuming the carpet. So you use hands to hold the handle. Forward and backward to do this motion. So you're holding the handle with your hand, but your arm are doing the forward and backward, okay, movement. So your back maybe will get affected also, not only the hand. And there is side-to-side motion of arm and wrist to turn vacuum. So when I'm using my hand, actually this joint here, this joint also is in movement and will get affected. My legs are used. My legs are used. So I walk and I'm vacuuming at the same time. This is also important. So what happens to the whole body? Okay, when using this product in this task step, because we divided the task into many steps. So each step now we need to tell about the action, what happens in this step, for example, using this human machine touching points. So we have the touching points, we have the task steps, but what are the actions? You need to describe that also in detail. Now, the more complex the device, if you have even the most simple tool can have a lot of explanations, but if you have a more complicated device, this becomes even more, the task steps will be more lengthy, the human machine touching points, then the actions. So the more complicated your device, the more of these steps and actions and everything you need to explain. So some observations for the design improvement of vacuum cleaner. This is just a few things that will help you understand the situation more. Like to make things efficient, you want to limit the actions as much as possible. Fewer actions equal less work. Now, if you have a lot of steps, a lot of actions to do, this means doing more work, which means what? Getting yourself more tired. So how can you reduce the actions to make performing a task more simple? This is about a vacuum cleaner, you know, like, so every device has its own like observations. You need to be able to form these observations when you do the analysis, because this is part of the analysis. This is the analysis, okay? For example, the power cord should be quickly accessible. You should not have to move other pieces to get to it. The area your hand and the cord needs to travel around, the guidepost, okay, should be free of obstructions. So when you read each of your task steps, and then the human machine touching points, and then the actions you wrote about, you have to think, okay? If you see, for example, that, okay, there is some kind of an obstruction, there is too many, for example, steps I need to do. How can I reduce this? How can I, for example, make it more easy, make it more simple, make it more efficient for the human to use to perform this task step, okay? How? So if you see a task step that has a lot of complicated movements involved, complicated things that could possibly cause safety issues or not be comfortable for the human, you have to ask yourself, how can I make it better? How can I improve it? So you need to basically write down your observations, okay? How can you improve? This is before you actually start improving. Here, you're not designing, you're still analyzing. You're analyzing and writing the observations in text. Later on, you start designing, once you have everything completed. For example, the plug of the vacuum cleaner should be easy to hold in your hand, easy to hold with enough size. So its size, the measurements should be comfortable for the human hand measurements to be able to be easy held. And the surface area, you know, the surface area, okay, must be in a way so that we can, when I hold it, I can get a firm grip so it doesn't slip from my hand, okay? So that when I pull it from the power outlet, it can be pulled easily because of its surface, for example, quality, texture, whatever it has, the material used, and the shape and the size. So I can pull it out easily and put it back in. And there should be plenty of room between you and the prongs because you're dealing with electricity here. So when I pull it out and pull it back in so that your fingers are in a safe distance, okay? So A lot of things to consider even for a small step. But when you read the task steps, the human machine touching points, and the actions you wrote, then you have to think, okay, now what are my observations? And write them down. So that later, when you have to solve the design problem or problems, so that you have a clear understanding of what needs to be solved. So I have to make this more easy, or that, for example, reduce, for example, the complexity, or. You need to have everything written down for you before you start designing. The handle, for example, should be comfortable and sized so that you have a good grip. The handle of the vacuum cleaner, you're holding the handle and you have to move forwards and backwards a lot of times to clean your house, okay? So imagine if the grip is not good, it's not comfortable. What will happen? You will get very tired soon. Your hand might try to compensate for a bad grip, and it will can cause health issues. So also the vibrations. Now, a vacuum cleaner is a powered device, so it makes sounds. You know the sound of the vacuum cleaner, and it vibrates. So you know this sound. So when it vibrates, imagine you holding a vibrating device for a long time. Actually, if you do it a lot, every day for several years, the nerves in your hand will get damaged. So you will not feel your hands the way you should. So nerve damage you can get out of vibration. So if you're using vibrating device a lot of times, like for example, the drill, okay, that you make holes in the wall. It's a vibrating device. So dampening materials have to be used. So dampen the vibration, okay? The texture also can, the texture of the material, okay, the surface, how is it, can also make the grip stronger and maintain control of a vibrating device. So these are all observations. After the task steps are written down, the touching points identified, the actions written down, then we have observations. Where are the problems? What do we need to basically look at and solve? Okay. So there is a lot more detail here. I will not talk about everything. You can read, and try to get a feel of how to write observations. The handle, for example, should be positioned so that you can maintain a natural wrist position, the wrist, this here, okay? Now, it should be, the handle of the vacuum cleaner should be bent, positioned, designed in a way so that when I do this movement, that my wrist, this joint, stays in a natural position, not unnatural. So if I have to move my wrist in unnatural positions, what do you expect to happen? Health problems, okay? So I have to keep my wrist while doing the work, the task, in a natural position. What can help me with that? The way that the handle is designed. This is a handle, okay? This is a handle where you grab with your hand. So the way the handle of the vacuum cleaner is designed should help me with keeping my wrist in a natural position while doing the task. A lot of things here. You can read them through to get a deeper understanding. There are many other, okay, now this is important here. There are many other tasks associated with a vacuum cleaner. So we talked about in general about what cleaning using a vacuum cleaner. But you have many other tasks. If you were analyzing the vacuum cleaner, is, for example, your device, you need to understand that there is, for example, other tasks you need to write about. For example, changing the bags. So, okay, you finished cleaning. You finished your task of cleaning. Now you have another task to do, which is changing the dirty bags inside and replacing them with clean. So this involves other task steps. So you need to open the vacuum cleaner, you need to take the dirty bag out. What do you do then? What is the next step? And so on, okay? What are the touching points this time? What are the actions? So this is another task analysis for another task. It's the same product, but another task you need to do, which is now cleaning, changing the bags. So, as I said before, be careful. Sometimes you have one product, but several tasks that you can do with it. So you need to describe them in separate task analysis. And you will have separate task steps, touching points, actions, and then observations for each one. This is all analyzing a device that is used by a human before, long before you can start any design. If you don't do the analysis correctly, your design will not be successful because you will miss so many details. You cannot just, for example, look at a vacuum cleaner and say, oh, okay, we have this problem here and this problem here. Maybe you can identify 1, 2, 3 problems, but you will miss 20 problems on the way because you didn't do a task analysis. Task analysis you should do in most of the designs you will get involved with before designing. And as I said, there are many analysis methods. We will also talk about another analysis method later on, the usability analysis, also used to identify problems and describe the problems so that later they can be solved using design, okay? So this is it for today. In the next lecture, I will talk about another analysis method, which is the usability analysis. Okay, thank you for watching.